Hello everyone, welcome all to Physics with Astronautics. So in this video we will discuss about some previous year IIT JAM physics paper. So let's begin. And here is the first question of this session, that is, a square laminar sheet with side A and mass m has a mass per unit area given by sigma x is equal to sigma naught 1 minus x by A, as shown in the figure. Moment of inertia of the sheet about y-axis each. And here the options you can see, and here is the figure. So here is our solution, that in the question it has been given that sigma x is equal to sigma naught 1 minus x by A, and we can write it as sigma is equal to dm by dA, that is dm by dx dy. So here dm will be sigma dx dy, and dm will be sigma naught 1 minus x by A dx dy. And again we know that the moment of inertia I is given by integration over x square dm. So by solving it, we can find that the value will be sigma naught 8 to the power 4 by 12. Again we have to find out the value of sigma naught, and we can find it from dm is equal to sigma naught 1 minus x by A dx dy. So when we integrate this part, we can find that the m value will be A sigma naught A minus A by 2, that is equal to sigma naught equal to 2m by A square. So by finding the value of sigma naught, when we will put this value in this equation, we can find that the moment of inertia will be 2m by A square, A to the power 4 by 12, that is equal to m A square by 6. So the final answer is m A square by 6. Then a particle is subjected to two simple harmonic motions along x and y axis, described by x of t equal to a sine 2 omega t plus pi, and y of t is equal to 2a sine omega t. The resultant motion is given by, and here the options you can see. So let's jump to the solution directly. And here is our solution. As in the question it has been given that y of t is equal to 2a sine omega t and x of t equal to a sine 2 omega t plus pi. So when we will solve it, we can find that y square pi 4a square is equal to sine square omega t. And again when we solve this x part, we can find that x of t is equal to a sine 2 omega t plus pi, and x by A will be sine 2 omega t into cos pi plus cos 2 omega t into sine pi. That is the sine A plus B formula. So from here we can find that x by A is equal to minus sine 2 omega t. Again, when we will square it, we can find that x square by A square is equal to minus sine 2 omega t whole square. So by solving this, we can find that x square by 4a square is equal to sine square omega t into cos square omega t. Again, we know that cos omega t can be written as 1 minus sine square omega t root over. So here this is cos square omega t, so we can directly write it as x square by 4a square is equal to sine square omega t 1 minus sine square omega t. And this sine square omega t is equal to y square by 4a square, as given in the question. So by putting this value in this equation, we can find that the final result will come out to be x square is equal to y square 1 minus y square by 4a square. Then for a certain thermodynamic system, the internal energy U is equal to PV, and P is proportional to T square. The entropy of the system is proportional to, and here the options are UV, root U by V, root V by U, and root UV. The question is, for a certain thermodynamic system, the internal energy U is equal to PV, and P is proportional to T square. The entropy of the system proportional to, and we have to find out how the entropy is proportional to U and V. So from the first law of thermodynamics, we do know that dq is equal to du plus pdv. And again we know that dq can be written as TDS, and DU will be written as PDV plus VDP, as in the question it has been given that U is equal to PV. So from here we can get that TDS will be VDP plus 2P dV. Again, P proportional to T square, so we can write P is equal to KT square, and from here we can get that dP will be 2KT dt, and when we put this value of P and dP in this equation, we can get that TDS can be written as 2KVT dt plus 2KT square dV, and this ds value will be equal to this value divided by t. So from here ds will be 2kv dt plus 2kt dv, and we know that this value entropy S is equal to 2kVt plus 2kVt when we integrate this part, and from here we can get that 4kVt. And again we know that P is equal to KT square, so from here we can write it as T will be equal to root over of P by K, that is equal to 4kV root over P by K, and when we bring this K value uh, in the root over, we can get it as 4 root K P V square. We know that PV is equal to U from the question, so we can write it as 4 root over of K U V. So the entropy of the system is proportional to root over of UV. Then the dispersion relation for certain type of wave is given by the omega is equal to root K square plus A square, where K is the unit factor and A is a constant. Which one of the following sketches represents Vg, that is the group velocity? In the question it has been given that omega is equal to root K square plus A square. So from here we can get that d omega by dk will be equal to 1 by root 1 plus A square by A square root over. So the sketches which match this value will be equal to option B. So the correct answer is option B. Then consider binary number with m digits, where m is an even number. The binary number has alternating ones and zeros, with digit 1 in the highest place value. The decimal equivalent of this binary number is, and here are the options. So when we solve it by it is trial method, we can found that the option D will matched. So the right answer is option D. I hope you all enjoyed the session. So for more videos, please like, share and subscribe. Thank you.